So today, very most important content quantum computing algorithm means you have to complex problem easily you can find this. What is the quantum computing means much faster classical computer and complex and means n by n means 1000 or 2000 by 2000 matrix or complex very more complex data you can solve easily quantum computing. That's why we can use this is timelines, time scale, theoretical foundation mean 19th century, 1995, 1964. First concept give to quantum hypothesis means Planck, next EPR paradox, next Bell inequality, and birth of quantum information theory. Next 1918, it is first conference on physics and computation. Next Simon quantum computer process and next emergence discovery of topological quantum order and 1984 quantum cryptography, this is BB84 protocol, and 1980 quantum computer and 2007 it is from superconducting web on 2013 it is computing and 2016 Microsoft Station Q, 2019 quantum Google quantum supremacy. Okay, and IBM quantum roadmap, and now there have some company also coming booming and develop qubit. Okay, and increase efficiency device performance. Okay, all the thing means nowadays develop. Okay, so basically this now going on. Okay, working efficiency increase, device and qubit increase, and there have lots of some company come DOF, Google, IBM. So basically this is open source nowadays. Can use sci-fi, SciSCF, BioPython, AstroPy, OpenCV Python. Means there have field free. This is all our library, and you can solve some problem, complex problem. Okay, or available you can use Jupyter Notebook or Google Colab. Install this sci-fi, then we can calculate or you can numerical computing this and use advantage math integration signal processing optimization and physics simulation and sim it is algebraic operations equation solve derivatives and sim computation and sci-fi you can use this quantum chemistry qskit you can use quantum computing it is created by IBM. Let's run quantum programming, real IBM quantum computer via IBM quantum cloud, and BioPython. You can use computational biology and bioinformation. You can optimize value. Ground state, you can find value, and you can easily find and use for DNA, RNA, protein folding, protein sequence analysis, structure modeling, and bioinformative data. Astro, this is already, it is basically use astronomy and astrophysics. It is also open source and use astronomer telescope data until coordinates and messing. And OpenCV, it is Python, computer vision, image, video processing, and free on it is open also this free access and used image recognition, video analysis, robotic and AI and vision tasks. Okay, these are library and it is descriptions mean which purpose you can use this all library and you can calculate value and optimize simulation and doing some work. Okay, and this is very most important topic means you have designed and this circuit how work. Basically there have some quantum on logic gate. Okay, there have some gate means one qubit there have some matrix from and you can when you can use quantum okay IBM qubit and you can see these symbols mean I X Y Z. Okay, AHHL means you have some apply algorithm and create circuit design you can circuit then this matrix and symbols and this operator gate is important means I did there have some operator gate basically identity gate. Okay, this is one qubit gate. Pauli X it is one qubit gate. Pauli Y it is also one qubit gate and this is matrix form. So and Pauli Z it is one qubit gate and this is matrix form. Control not X it is two qubit gate. So two qubit gate X and control Y to control Z, 2 qubit, phase gate, it is 1 qubit gate, and phase gate 3 pi by 8, pi means 180 by 8. Okay, so this is 1 qubit gate, and also memorize this whole matrix form. And Hadamard gate, it is 1 qubit, Swave gate 2 qubit, and TOEFL gate CC naught, CCX, and TOEFL 3 qubit gate. So first, basically, you have knowledge to get. Okay. Next, we can move in our main focus. There's some topic algorithm. Nowadays, there have some algorithm you can optimize a value and you can get result. So basically, algorithm is most important. Means you can why this algorithm most important because you have data, then you can optimize, you can use different algorithm to not use this one algorithm every field. This is not possible because different field, different branch, there have some different problem, different concept. That's why we can use value different algorithm and different concept. And first, basically, and cyber security, we can use some algorithm, source algorithm, quantum key distribution. Post quantum QC, it is lattice based, code based, hash based algorithm, and there exists source algorithm. I explain. Okay. So next topic, it is optimization problem. Optimization, when you have data, then you can optimize this data. Which formula you can use? QAOA, basically quantum approximate optimization algorithm. Which problem this algorithm solve? It is NP hard problem, logistic, routing, scheduling, timing, this like that problem solve. Work with Cubo and Ising model. Next, Grover's algorithm. It is speed up unstructured search root N and useful in data search matching and some VQ, variational quantum eigenvalue for optimize. This is very most important algorithm. Sometimes used to solve problem by energy minimization. If you take any value, then it is solved minimization energy you can. Okay. And drug discovery and chemistry, this is you can optimize and you can find also ground state energy. We can use which formula you can use b you mean variational quantum eigensolver, you can use this formula. Okay. And you can solve this problem. And working, it is NISQ device. And suppose you can use more qubit than NISQ, it is more means noise problem more. Next, quantum phase estimation, QPE. It is very accurate molecule calculation, needs fault tolerance qubit, Hamiltonian simulation, models chemical reaction and electrons interaction. Next, algorithms. And this algorithm you can use artificial intelligence, machine learning, quantum AI. SQSVM, quantum support vector machine. It basically fast classification than classical SVM for some dataset. Quantum key means quantum clustering, speed up, grouping, and pattern analysis. Okay. HHL, this is solve linear equation means D, and used ML training and regression. I also showing how you have data you can solve, use quantum computing and you can solve in your data and you find solution. Okay. Next, amplitude amplification. It is increased success probability in machine learning algorithm. Okay. Next, first you know these all algorithms, then these all algorithms, which purpose you can use and which value you can find. This is very most important. Material science, you can use some algorithm VQE and QPA. It is used simulate material superconductor and quantum law. It is sampling quantum system. It is faster. Next, finance and risk modeling. You can use QAOA. It is portfolio optimization, resource algorithm means allocation, and amplitude estimation. It is speed up Monte Carlo simulation, faster option picking. Groves algorithms also fast search financial data set. Next, climate and astrophysics modeling. It is quantum simulation algorithms. It is model chemical reactions in the atmosphere. And Hamiltonian simulation help in understanding molecular behaviors in climate science. Next, cyber physicals and IoT security, QKD, quantum chromodynamics, BB84E91. You can use this algorithm. And ultra secure communication for IoT device, quantum sensor, improve GPS navigation, climate sensing. Okay. Next, this is some you know about that some algorithms and which purpose you can use this algorithm. But now times I discuss about this algorithm mathematical from input and output, which value you can give input and what you can take output. This is very most important. Okay. Quantum gate model algorithm, it is algorithm, it is input hidden binary string and output it is recovered string in one quantum application. It is shows quantum parallelism power. Simon's algorithm, it is input it is with hidden XOR marks and output secret XOR marks. And application basics for solve algorithm and exponential speed up. Next solves algorithm input integer and output prime. Application it is break RSA encryption number theory cryptography and quantum transform. It you know some people also it input quantum state and frequency component. And application used in source algorithm, phase estimation, signal processing, this like that. And quantum phase estimation QPE, it is input unitary operators U eigenvector and output it is eigenvalue phase of U. And application is chemistry simulation source algorithm quantum sensing and Grove search algorithm it input function and storage database with in output target items order of application search optimize and analysis. Next topic variational quantum algorithm hybrid. Variational quantum eigensolver you can give input Hamiltonian of molecule output ground. Okay. Application quantum chemistry material science drug discover quantum next algorithms it is quantum approximate optimization algorithm QAOA. It is basically combinational optimization problem. It is output approximate optimal solution. Application traveling salesman problem max car Cubo problem. Cubo basically classical solve problem. Okay. Quantum machine learning variational circuit is induces VQC QNN QSVM. It is application image clarification, pattern recognition, finance, drug discovery. Okay. Next, quantum optimization algorithm QO. This quadratic unconstant binary optimization. It is binary quadratic cost and output if you give binary variable and quadrant output you can take minimum energy solution. Basically quantum computing is which type of problem solve means you have give any complex data and they output minimum energy ground state level energy and minimum solution minimum cost just like that. Next application it is logistics scheduling and portfolio optimization value. Next quantum optimization it is for encode and Hamiltonian and output lowest energy solution. Okay. Next application it is annealing machine. It is example deep machine learning algorithm HHL algorithms. It is basically quantum linear system solver. Input you give to matrix. A matrix means 2 by 2, 3 by 3, 4 by 4, 5 by 5. Any matrix means you can 100 symmetry matrix, unsymmetry matrix. Then can find the solution X. X is equal to B. Application machine learning, engineering, simulation and recommendation system. And quantum PCA input it is density matrix, output is principal component. Application data comparison pattern recognition. Quantum K means data set and output cluster level. Application it is customer segmentation, image grouping and large data analysis. Next quantum simulation algorithm it is basically some same topic means you can input Hamiltonian simulation and output evolutions of quantum system. Application you can use chemistry, physics, material science and production algorithm. Input it is Hamiltonian H, output approximate time to the power iota H. Okay. Next topic it is quantum cryptography algorithm BB84. Quantum key distribution. Input random qubit output secure encryption key application unbreakable communication. E91 protocol entanglement secret key and application long distance quantum communication. Quantum error correction algorithms, source code and surface code. It is noise qubit output, it is logical qubit with reduced error and application fault tolerance quantum computing foundation. Next, there are some algorithms input output and application source groups QAOA, VQE, variation quantum eigensolver, QPE, HHL, BB84. This is input, this is output, this is application where you can use this algorithm and which type of you have data input and implemented solution. Okay, integer n is equal to t. Okay, and this speed up it is exponential growth, exponential speed up. Next, Grover's algorithm, same thing, means this is your Grove's algorithms unstructured search, and it is time complexity, it is classical and quantum time complexity order of root n and classical order of n. Speed up it is quadratical. And next it is QAOA quantum approximate optimization algorithm. It is objective minimum cost function and bit string z alternately applying unitary operators. And this is input function and output function you can see, and time complexity it is time complexity is equal to order of pc, means p means number of layer, c means cost Hamiltonian, and time complexity you can see order of p into n number of layers, and c means cost Hamiltonian evolution complexity. Okay, next you can memorize this mathematical equation and time complexity. Next, this is process you can QAOA when you have applied this formula, and you can find cost Hamiltonian and mixed Hamiltonian mean AC and HM, and means 1 2 3 4 anything can use, and also you can optimize this value and you can take get result and you can draw circuit. Okay, next same thing means quantum annealing basically is cost Hamiltonian AC. Okay, and output minimum energy if you give cost Hamiltonian AC value, and you can take minimum energy configuration, and you can compare in your classical data and quantum data which is better and how much to take time. And this time complexity to order of 1 by delta square. Delta square it is basically minimum spectral gap, it is sometimes exponential if gap is small. Okay, next topic VQE, variational quantum solver. This is mathematical equation. It is goal find ground state energy E0 Hamiltonian H, and this is quantum complexity order of n square, and classical order of 2 into 4n. This is exponential, but quantum it is polynomial order of n square. Okay, next topic QPE, quantum phase estimation, unitary U eigen state. Okay, it is input unitary U and eigen state psi and output phase phi, and quantum complexity T is equal to order of 1 by square. Okay, next topic it is variational quantum eigensolver. It is Hamiltonian H and parameterized psi, and output if we approximate ground energy is 0, and it is exponential value and optimization data. Next, there have some difference quantum and classical VQ and SQ. And next it is QPE quantum phase estimation. Estimation phase phi is I, and HHL algorithms linear system solver AX B and out A inverse B. The QPE count of eigenvalue of A. Okay, HHL you can solve linear equation system. Okay, and is ground state energy you can find. Next, quantum machine learning. It is quantum complexity. It is Q. K means input. It is cluster and point. Put and output you can take estimate of probability A, and time complexity also classical and quantum you can see quantum complexity order of and classical Monte Carlo T classical it is 1 by epsilon square, but this curve showing it is quadratic. And quantum simulation it is Hamiltonian evolution, input Hamiltonian H and time t is an output psi t to the power minus iota is not, and approximate this equation you can use and change value and you can take get result output state. Okay, and time complexity, this is order of t polynomial log n, and improve algorithm achieve order of log n. And quantum walk search graph algorithm, this same thing also discrete time quantum walk graph Hamiltonian input, it is graph G Laplacian L, and output distribution over graph node. This is time complexity order of log n, order of n square. And quantum PCA density matrix and output mu, and this is BB84. This is input random bits plus bias and output shared secret. And time complexity, it is algorithm complex, not an algorithm complexity. Measure one qubit operation order of n. This is linear in bit count. And counting quantum quantum complexity order of root n, I already said. This is quantum minimum finding order of root n, and quantum clustering order of log n, and classical knn, it is order of n. And discharge George algorithm order of 1, and t order of to the power n. Specific there is how this is growing. This is growth versus classical search log classical order of n, like that straight line curve. Okay, straight line means linear graph, it is increase, showing this graph. And Grove's root n, this like that. And Shor's order of n square log n log n log n, this like that, showing it is exponential. And polynomial, you can see this polynomial curve, and exponential also you can see. And a QFT transform order of n square. Okay, okay, and this is complexity and matrix dimension. Okay, classical dense solved order of n cube, and HHL order of k square log n, k is equal to 10. You can see this curve exponentially increase. Okay, some graph. And polynomial order of n cube iterative, it is you can see you can bit string increase, but complexity is not increase. Okay, this is polynomial. And source order of n square log n, we can see this graph. Next same thing, if you increase number of qubit and versus complexity, you can see this. If you increase QFT number of qubit, it is increased, but complexity it is not increased. Okay, this is constant. Next, time complexity versus problem sized n, this is both increase. If you increase problem size, and time complexity also increase. Next, it is same thing, target error and smaller harder, and versus sample cost. It is classical Monte Carlo on by epsilon square. You can see this curve, it is increase, this also increase sample. And cost function also increase when VQE measurement on by epsilon square, and optimize, it is constant. Next, there have some curve means order of n factorial, order of this is exponential. And order of n cube, it is cubic. Order of n square quadratic. And order of log n, it is logarithmic. Order of on, it is constant. You can see different data input and time versus graph. Okay, next, this is challenges mean with some doing work, there have some technology means superconducting qubit, it is example, it is IBM and Google doing work. Okay, and approx 100 to 500 micrometer trap ion qubit size 5 to 10, and spin qubit 5 to 10 to 100 nanometer. And photonic qubit depends on, and topological qubit there have some. Okay, now some different platform also doing work means superconducting qubit, some industry use trap ion spin qubit, photonic qubit, and okay. And this is quantum qubit limitation. And quantum qubit limits the properties, type values, and some which is based, or which is most important. And suppose they have coherence time means 550 to 150 microsecond. Superconducting 1 to 10 second ion, it is qubit lifetime. And gate error rate, 10 to the power minus 3, 10 to 2, 10 to the power minus 5, it is low and better. Readout error 1 to 5%. Measurement connectivity limitation, degree restrict circuit design. And temperature, you can use 10 to 20 Kelvin. And quantum ground and logic qubit requirement, one logical equal to 200 to 1000 physical, and it for fault tolerant. This is now 2025. There have some company technology and maximum qubit, and they can give free access. This is very most important. Suppose you have any problem in any material science or astrophysics, or you can use cryptography also, but you have need more qubit, 10 qubit, 200 qubit. Then how? There have only some company free platform give to qubit, means IBM 5 qubit only free access, but they made 1121 qubit they made. But only free 5 qubit. Google also no, Microsoft limited they have no, and maximum qubit they are made 84. D-Wave also 5760 qubit. Cura it is ion quantum, it is trapped ion, it is superconducting, and D-Wave annealing, and Cura it is neural network. They have some doing work. And how many qubit you can use today? It is free already, say IBM 5 qubit, D-Wave annealer 5760 annealing qubit, Cura it is simulators 256 qubit, Amazon, Google, Microsoft only 40 to 50 qubit, and there have some paid. You can purchase this qubit and you can solve complex data, and you can use this algorithm and you can find result. You can use this formula, which algorithm you can use QAOA Q, okay, and you can solve and get result. This is your LinkedIn profile. You can follow, share. You asked any question. Thank you. Okay, okay. You have any problem? Anything?
Will ask.
Okay, so thank you. But I showing one thing, means this practical one thing how we can get result and doing code Python, and which type of you can get result. Okay. 1 minute. Suppose now screen is showing now. This is your, suppose you have matrix. Okay, means 1 2 3 4. You can take matrix 1 2 3 4, and you can apply HHL algorithm. HHL basically solve linear equation. AX is equal to B. Okay, then which type of you can take value? You can see this value is classical simulation invert 1. B it is -2 and 1.5. B 1 10 14 14 20, and eigen value this, and eigen vector this is your eigen vector, and QASM count. Okay, this like that you can take result. Okay, so this part I explain next time. Okay, I showing this practically how you can optimize value and you can get result, and which types of showing curve, everything. Okay, so thank you
One question, sir.
yes, yes.
Suppose the drug discovery
Yes, yes.
in drug, especially in healthcare, especially in digestion system, complete chemical reactions are going on. Suppose in this process we are going to use drug discovery algorithms, particularly which algorithm we are going to implement to what is going on in our digestion system. Based on that one, this diabetics and everything we are going to
uh,
find out.
Okay, okay, understood. This is drug discovery. You can use some algorithms in EQAOA, quantum approximate optimized algorithm. Okay, and you can also use Cubo. This algorithms means chemistry purpose. Means this is bio Python. You can use library, and this is also open source, and you can analysis data, means minimum data optimization, minimum value eigenfunctions or ground state level. You can take data only these things.
Okay, thank you, sir. Thank you.
Uh, Also, all one thing you can search paper, or you can search this algorithm, and VQU also you can use variational quantum algorithm. You can use this algorithm and you can solve this problem.
Okay, sir. I am reaching in this one, sir. Actually, that's why I.
No problem. You
Yes.
can see this part. You can take screenshot this drug discover, drug design, material science, and quantum chemistry you can use, and you can see this input Hamiltonian or molecules you can give input, and output also you can take ground state. Okay, you can
Thank you, sir.
see this mathematical form algorithms, or you can study this QAOA and VQE, this mathematical equation how you can use in your data in mathematical form, and you can take which type of data and you can compare classical data and quantum data. And also there have some time complexity also important. Which type of can use time complexity? Okay. You have asked any question or you can show me anything I can help you, no problem. Okay, so thank you. I share my LinkedIn profile or you can also message you have any problem or anything. I can help you, no problem. Thank you. Okay, bye.